Okay, so today we're going to be able to create, that's our main learning target, we're going to be able to create inequalities as well as graph them. And also today we're going to be able to identify solutions. So you kind of have two newer learning targets, creating the inequality and identifying solutions. So when you write inequalities from a graph, I'm going to make it sound super technical, but it's actually kind of, well, not easy, but it's not that bad. You identify where the circle is. That's the number. So maybe you don't even want to write circle. Maybe you want to say number. It's wherever the number the circle is on. And then you want to determine if it's colored in or not. And you can tell if you color it in, you put a line under the inequality. If you don't color it in, you don't put a line. And then you're going to write it. You might want to refresh your memory. An inequality symbol like this means greater. An inequality like this means less. So did I leave yours blank as well?
No.
You have a number there?
Yeah.
Oh, you don't have a circle though. You just have, you don't have a circle on these number lines, right?
No.
Okay, I'm gonna make a circle and then we're gonna have to write what the inequality means, okay? What inequality is that? So that's our learning target today. You're gonna be given an inequality and then you have to write it.
Does it matter what variable we use?
No, you can use any variable you want. I typically use x. So I'm going to say x, is it bigger than or less than?
Big.
It's going to the right, so it's bigger, and I color it in, so you put the line. And then am I, what number?
-2.
Good, there you go, learning target done.
Okay, why do you do the underline?
Because I colored it in. Underline means color in.
But why?
Why what?
Like, why does it matter if it's, why does it matter?
Oh, why does it matter if it's colored in? Because this is saying that x can be anything from -2 all the way to infinity. If you don't color it in,
Oh, because
then you can, this is saying you can be -2. So x can be -2. This is saying it can't be -2. It can be -1.999, an infinite amount of nines, but it can't be -2.
Okay.
That's why. Okay, make a circle.
yeah,
Make a circle right here and go this way. Make the circle. So I start with my variable. So I'm going to say x. Am I greater than or am I less than?
Less.
Do I put a line under it?
No.
Yes.
Yes.
Okay, what number?
0.
So do you see our strategy? Put the letter, are you greater than or less than? Number. Letter, greater than or less than number. That's our strategy. Okay, put a circle right here
In between?
in between.
That's hard though.
No. Do you see that beautiful open area?
Nope.
Well, it's not colored. Okay. So variable, am I bigger than or less than? Bigger, not colored in, so no line. And then what number is this?
3.6.
3.6. I'm going to say 3.5 just because, but if you say 3.6, fine. Well, not for this. Okay. Ready? I want you to do Is it greater than or less than? Do I put a line under it? What number?
-3.
Alex?
Yeah?
X is less than or equal to
Is
negative
this what we're doing today?
Yes, it is.
So we're not doing
I
the
like
back.
It's easier.
Yeah, we're doing the back.
Oh no.
Identifying solutions is the next one.
I heard it was dying of.
Sidebar conversation should be done. So identifying solutions, what you want to do is plug the numbers in. Plug it in. And then determine if it's true. You know how to determine if it's true. It's just a lot of work, and you have to do this today, and it's a lot of work. But only a few problems. So I want to know for the following inequality, 2y plus 1 is bigger than 6. Is 1, 2, negative 3, and 0, are they a solution? Watch the tedious math involved. So I say, I want to know if 1's a solution. So I plug 1 in. 2 times 1 plus 1, is that bigger than 6?
I get it.
2 plus 1, is that bigger than 6?
No.
3 is not bigger than 6. No, 1 is not a solution. So what I did is I put this in there. Now I'm doing that for the next number. See, look at how many different things I have to do. So now I'm going to put the 2 in here. Does 2 times 2 is 2 times 2 plus 1 bigger than 6?
Yes.
Is 4 plus 1 bigger than 6? Is it? Is it? No.
Yes, no. It's 5.
Is 5 bigger than 6?
Yes.
No.
No, let's not give people the wrong idea. 5 is less than 6, so no, it's not a solution.
Let's do D.
Let's do C. Okay, now do C.
Welcome back.
Okay. So C is negative 3. So 2 times negative 3 plus 1, is that bigger than 6? Is negative 6 plus 1 bigger than 6?
No.
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 And D is 0? Are all of these? No.
Yeah.
Maybe.
That's not always the case, just so you know.
D.
This
I know
is
it's right.
0 plus 1, is that bigger than 6?
Yes.
1 is not bigger than 6, so no, it's not a solution. It's not natural words. On the back of your notes, if you have a spot available, you might not, but I want to introduce you to word problems because you have some of them today. Word problems is just creating an inequality. I do want you to know that there's common vocab words. There's an at most. So it's going to say at most the bus can fit 70 kids. Is that greater than 70 or less than 70? If you say that a bus can at most put 70 kids in there, does that mean kids can be more than 70 kids or less than 70?
Equal or less?
Less than or equal, yes. So at most is a common vocab word that kids struggle with, and then there's another common vocab word, at least. For example, you're going to Valley Fair, and they say in order to ride this ride, you have to be at least 52 inches. What does that mean? Do you have to be bigger than 52 inches or less than?
Bigger.
Bigger than. So at least means you are bigger than or equal to. That's the common vocab word that you're going to see today with a word problem. I'm going to create one, and we're going to make an inequality from it. Okay, so here's a couple word problems modeling inequalities. Let's say you are having a a party. Your family says that you should invite at least 20 people. Write an inequality that models this. So, I'm gonna say people. So if it's at least 20 people, should I be bigger than 20 or less than 20? At least, look at least. Bigger than or equal to 20 people. Okay?
That's it.
My classroom or this classroom has 36 desks. Write an inequality that represents how many students can be in my class. 36 is at most. That's the most kids I can have. So, is it less than 36 or greater than 36? I have to have less than or equal to 36 students. So my students have to be less than or equal to 36.
Is that all we have to do?
Yeah.
Pretty easy. Is it a worksheet?